Hi, welcome back to Moose in Chemistry. This is Electromagnetic Spectrum Problem 1 lesson. Okay, in today's problem, we're going to look at the wavelength of green light is about 522 nanometers. What is the frequency of this radiation? Now remember that frequency is the number of wavelengths that pass through a given point in a second, right? So this would be the frequency, just like this. All right, now given that, let's look at this. Okay, so what do we know? Well, we know we have 522 nanometers. So write that down, 522 nanometers. But we're going to be using the formula C equals lambda V, okay? So the first thing we have to do is we have to convert nanometers into meters because the speed of light right here is measured in meters per second. So let's do the first conversion. So we go 522 nanometers times 1 meter divided by 1.0 times 10 to the 9 nanometers. Because look at this, in 1 meter there is 1.0 times 10 to the 9 nanometers. Alright, so now we're going to figure out our meters. So we cancel out our nanometer units, divide 522 by 1.09, and that gives us 5.22 times 10 to the -7 meters. Okay, now that we have that, we're ready to do this. So let's take C lambda V here, and let's change the formula to equal frequency. So frequency equals C over lambda, right? So now we're going to go V equals the speed of light. We're going to use 3.0. We could use 2.99, but we're not going to get that much difference. 3.0 times 10 to the 8 meters per second divided by our meters here, right? So we're going to get 5.22 times 10 to the -7 meters, right? Okay, so now our meters are going to cancel out just like that, and our frequency is going to equal 5.75 times 10 to the 14 1 over s minus 1. Okay, so now you say, well, wait a minute. Can we also put that in hertz? Sure, because remember that hertz, right here, this is hertz. Hertz is equal to 1 over s minus 1. See that? So we can either answer it this way, or we can say V equals 5.75 times 10 to the 14 hertz. Okay, well that's it for this lesson. You guys be snarly, and we'll see you back here at Moose in Chemistry.